the another important theorem on probability, that is multiplication theorem on probability. Now, what is its statement? Let E comma F be two events E comma F be two events of a sample space and the probability of E is not equals to 0 and the probability of F is also not equals to 0. Then first one, the probability of E intersection F is equal to probability of E into probability of F by E. The second one, the probability of E intersection F is also equals to probability of F into probability of E by F. So now this is the statement. Let E comma F be two events of a sample space in any random experiment with the probabilities not equals to 0, each probability not equals to 0 but less than 1. Then probability of E intersection F is equal to P of E into P of F by E, and P of E intersection F is also equals to P of F into P of E by F. Now already we have the definition for conditional probability. What is that? E by F is called conditional probability, is called conditional event. It is a conditional event of the sample space S. And then the probability of E by F is called conditional probability. So it is already defined that probability to the conditional event is always conditional probability, and also defined as P of E by F is equal to P of E intersection F by P of F. Now on cross multiplying, it is P of E by F into P of F is equal to P of E intersection F. Therefore, the probability of E intersection F is equal to probability of F into probability of E by F. So, P of E intersection F is equal to P of F into P of E by F. So, it is the second one. Next one, in the same way, F by E is also a conditional event. Now, the probability of this conditional event, that is probability of F by E, is called conditional probability. Conditional probability. Now, by its definition, probability of F by E is equal to the probability of F intersection E by P of E. Now, on cross multiplying this, we get P of E into P of F by E is equal to P of F intersection E or E intersection F, whatever that, no problem. Both are same. Therefore, the probability of F intersection E or E intersection F is equal to P of E into P of F by E. That hence the theorem. So now we derived the multiplication theorem. Suppose if A comma B are two events in a sample space S, and the probability of A intersection B is proved as P of A into P of B by A, or that is also equals to P of B into P of A by B. So it is already proved. Suppose if there are three events, A, B, C are three events belongs to sample space S. A, B, C are three events in a sample space S. Now let us find the probability of A intersection B intersection C. Now here let us we take A intersection B is equal to some D, some event D. Then it is P of A intersection B into probability of C by A intersection B by the above theorem. Now we can write this P of A intersection B again as P of A into P of B by A into probability of C by A intersection B. Therefore, the probability of A intersection B intersection C. So A, B, C are three events. Then the probability that the three events occur at a time is equal to P of A into P of B by A into P of C by A intersection B. Now, in order to consider, suppose if there are A1, A2, A3, so on, AN or N events in sample space S, then probability of A1 intersection, A2 intersection, A3 intersection and so on intersection AN is equal to P of A1 into P of A2 by A1 into P of A3 by A1 intersection A2 and continue like that, and P of AN by A1 intersection A2 intersection and so on intersection AN minus 1.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.